Alright, hello. In this video, we're going to work on the buffer overflow prep on offensive pen testing learning path on TryHackMe. Let me be honest, this is one of the most frustrating room I ever encountered because there are so many steps to run through. The exploit itself, it's not that difficult, but to get the buffer overflow to run, there's a lot of steps. And the way the room creator, I think Tiberius, I liked him. He's a great content creator and also a real life hacker and malware engineer and so on. But this one, I gotta tell you, this is pretty confusing in terms of like reading through the description and make sure you're following on the step and basically get the exploit to run. So I'm just gonna go ahead and do the simple step on how to get there instead of just reading everything, because honestly you're gonna see me switching between this tab of the TryHackMe room and this other tab where I put all my notes. It's basically a Notion tab. Text is really small, but don't worry. It's the purpose of this. It's just I break down the step to bullet points, so it's much easier to like read through and following the step instead of reading the whole paragraph, because the way it was written, look at this, like you don't know where you're at a lot of the time. You just come back and forth between the tab and you're just not sure where you're at. So it's just like really confusing for me at least. And if you have any more trouble, honestly, look up write-up. There's one by Hellstorm Security. I also like his write-up too. Their write-up is not confusing and it give you a good enough step. But I'm not gonna use this write-up. I mean, I'll come back if I get stuck. Ultimately, purpose of this video is not me being the expert, quote-unquote expert, on solving this room. It's just me trying to figure out this room, just like you watching, basically. And I've done the first task, but many other tasks I haven't done yet. It's basically repeating the first task over and over until you finish the room. So let's just jump straight into it. First thing first, once you deploy your instant, the IP is basically changed for you to whatever instant you launch. So it's automatically correlate the IP to whatever instant you launch. So it's better to keep copy all the command from the room like this. This is a free RDP, so you basically connected from remote desktop protocol, X3 RDP, and this is what it will launch. We're gonna see Windows 7 professional, and it is really slow. That's part of the reason why it's kind of frustrating to do too. We're basically running a VM on top of a VM, and yeah, so click on home network. I think it's where we're supposed to click on, and as you can see here, this, like in this paragraph alone, there are probably 3 different steps. That's why I want to break this down. So do not mind the small letter. I just want to see, I'm gonna read over the step and then we'll continue on step by step instead of just going back and forth. Again, this is the copy of the room description. I just copy everything and I just break it down to bullet point, so it's much easier to follow. So we're gonna open up Immunity Debugger and actually open it up as administrator. That's our first step once you connect to the remote desktop protocol. And as you can see, it take a bit to load because everything is really slow on here, and it's launched all of these tabs. So first thing first, we can open the file. We could choose all the way back to C, and then we're going to go to user, admin, desktop, runnable apps, oscp, and then click on the oscp binary. This should launch all the tabs here. And as you can see, the letter is really small, so my tip for you to make this a little bit bigger for those who have difficulty in your eyesight and whatnot, and try to just see it bigger. To be honest, if you have bigger monitor, it's also help too. I prefer something with a bigger font. So all you need to do is go to font, change, and I prefer Courier New, and I choose regular font style, and I usually pick somewhere around 18 and 22 or somewhere like that. It's gonna make it a bit bigger and much easier to look at. And I also like to space out the assembly code, so all these tabs here, make sure see all the letters and whatnot. It's just my preference. It's also much easier to read through what's going on because these these can be very confusing, so I like to space this out a little bit more like this. As you can see, it's not the best, because again, we're running a VM on top of a VM, and it's, you know, it's a lot. It's there it is. Well, it should be fine now, I think. Gonna move some of these. All right, so once we launch the apps and the binary, once we open it, it's basically on a pause state, as you could read on this. It's around here. Yeah, click open, debug, run. So we have to run it. The way we run it, we want to press on this red play button here on the top left and get that to play. What it does is basically run the binary on the debugger, and the binary is basically some sort of application where it's just listening to it's kind of like a netcat connection basically. So as you can see here on our Kali box, connect to port 1337 on the IP. So instead of copy what I have on the Notion, it's basically switch back to this TryHackMe tabs. This is the new IP that we use. So the new IP is just basically whatever instant you launch, and it basically open up a netcat connection. And the way we see that it connects, you see oscp vulnerable server and a helps, and there are 10 overflow options. So the first one we choose is basically the overflow 1, and the type overflow 1, and then type test, and you see completed. That's mean it's good, and you could cancel the connection for now. And once we're done with that, we have to restart the binary again. So the way we do it, we basically press on the replay button, this black to backward play button here. That's how we replay the binary. And then we see the motor script is pre-installed. However, it make it easier to work, you should configure a working folder using the following command. So just copy and paste this command on Immunity Debugger. So it's basically is at this bottom part of the apps. So Mona configs pack set working folder, C Mona %P. I think it's just where we place all our working folder. So you can see here, creating a configure file, setting parameter working folder, new value of the parameter working folder. That should be running. And next up, you can copy this fuzzing.py or fuzz.py onto your Kali machine. So I'm just gonna open up my folder. I already have the folder for this room. So buffer overflow fuzz.py. So again, it is better to just copy the new Python script from the room itself, since it is configured for this particular IP. Save it. I save it as fuzz.py, like the room wants us to do. And so you saw me replay the binary, so all we have to do now is play it again, and it should be running like before we do the NC. So this time we're just gonna open a new tabs. I'm also gonna cd to thm buff over prep, and I open a few more tabs just in case. We're gonna use a lot of tab here. I want to make sure everything is completely organized. Better to be organized in this room. So we're just gonna run Python again. I'm just gonna ls just to make sure. So you see fuzzer.py here. This is the one we want to pay attention to currently. So we're gonna run python 3 fuzzer.py. Oh, I mistyped python. So what it does is basically the script gonna send 100 byte at a time, try to test the application, and it's gonna find the bar, basically the limit of the buffer. What buffer overflow does is to go past the buffer side and basically go over the stack, and with the malicious code we can basically use that exploit to create a connection back to our machine, and use that vulnerability to do a remote code execution basically. So it's gonna try to send 100 bytes at a time, and it's gonna do a while loop, and once it hits the limit, it's gonna basically stop and tell us what byte does it run. So you see here, fuzzing crash at 2000 bytes. That's something we want to note. So you saw my notes here, and we could look at the EIP, and you can see here we kind of crashed the binary with the fuzzer, and it's basically input AAA of 4141, which is meant AAA to the binary, and it's basically crashed the binary. So that is the result we want to see. So we could replay this binary again, press the black to replay button on top left. All right, so next up is the crash replication and control EIP. So we see, earlier we saw 41, 41, 41. This is the exploit.py. So we have to copy this new script. So it is different than the buzzer.py. It's a little bit more line. Basically, just gonna open this up with the existing exploit.py in here. As you can see here, this is the part where we have to figure out the correct numbers and basically input that to the Python script. So these 1, 2, 3, 4, 5, 6, 7 line, this is the one we want to configure. So once the ultimate goal for this is to find the right input. So whatever we write in this quotation mark here, so find the right input and make it make sense that the Python script basically do the buffer overflow attack correctly with the input we put in and basically gave us the remote code execution. So this is what we want to find out and put it to our Python script. So this is something we're configuring right now. So run the following command: generate a cyclic pattern of the length 400 bytes longer than the string that is crashed the server. So what is 400 bytes over 2000 is 2400 bytes. So instead of copy the whole line, you see here, so instead of copy and write 600 byte, we basically want to go over that. We want to go to 2400 because again the fuzzer crashed the binary at 2000 bytes, so we want to go over that 400 bytes longer. So this is the command. So we copy this result. We basically use the Metasploit framework tool exploit pattern create RB, and then we basically copy this to the payload section at line 11. And I'm also going to use warp. So if you're on Sublime, view word warp gonna help us see the line like this instead of going all the way to the right. But this is better to like look at the script in my opinion. And I don't know why this thing kind of messed up. So let me recopy that. Sometimes stuff like that happens, so make sure, yeah, it's doing its random thing. So it works like this, and then once I zoom in, it's not. I'm just gonna assume it worked fine. Well, maybe not. What happened? Copy that again. It doing its random thing again. I think it's just the way it is. I'm gonna save it and open up again. See any different. Use warp. Yeah, it just does the thing. So it really doesn't matter. I mean, warp or not, if as long as the line doesn't disconnect and create a new line, I think it's fine. It doesn't look like it's anything bad. This is the way it is. I think we're just gonna have to continue on. See here. Okay, look fine. Right, so save it. And if you are on attack box, you can use this line. So follow the step. So again, we copy the output onto the exploit.py on window Immunity Debugger. Reopen the oscp.exe again. So we already restarted. So just to make sure, we do the replay and play it again. So it is running. You see here at the bottom, right? So we have to do this every time we try to run exploit.py. So we have to restart the application over and over. So next up, once it is running, we're just gonna go to a new tab. That's why I like to open a decent amount of tab, because it's better to just be organized, because it can be confusing again. So we have to run exploit.py with Python 3, and it is running. As you can see here, this kind of crashed the binary again, and it is in the pause state. And couple things we have to note is the ESP and the EIP. It's changed. So next up, we have to copy this Mona find MSP distant here. And instead of looking for the 600, we have to type 2400. And while we're doing this, we basically try to look for the offset of the EIP. Contain, as you can see here, examine register. EIP contain normal pattern 0x6F43396E. Offset is 1978. So we have to write this down. So this is our offset. So as you can see here, we try to configure the offset. So we have to write 1978 on our Python script exploit.py here, and this would be your first answer for the task 2. So basically I skip all of this, and if you want to check again and see if it is different, so as you could remember, the first attempt we try, we saw 41 41 41, but this time we want to see if it changed, if we change the variable on the RETN. I think it's return. So on this section on line 9, all I have to do is do 4b and save it with the offset of 1978. So let's give it a check. So we restart the binary again and play it, have it running. Make sure you save the offset and the return line on the line 9 and line 7 with the payload that we generated, and basically run the Python script again, and there it is. So we basically input the offset where EIP is placed, and basically write the return to BBB. So it should be 4242. As you could see here, you could note that it is 4242 at the EIP register. So that's something we are doing correctly. All right, we're gonna move on. So we've done the step correctly. Make sure you get the 4242. We're going to find the bad character to generate a byte array using Mona. Exclude the null byte /x00 by default. Note the location of byte array.bin file is generated if the working folder was set per the Mona configuration section of this guide. Then the location should be Mona oscp byte array bin. So all we have to do is copy this line and paste it on the bottom part of Immunity Debugger. Press enter, and you see here resetting log file. This is what we want to see, and we have to open this file here using the explorer.exe and computer, I think C drive, Mona, oscp, byte array.text. So we have to read this with the notepad, and I'm also gonna have to zoom this too. That's status bar. I cannot zoom in. That's interesting. Edit what? Format on, and then just change it to 20. Easier to read, right? Okay, this is what we want to look at. So now generate a string of bad char that is identical to the byte array. The following Python script should be used to generate the string of bad char from /x01 to /x01 to /xff. So I'm already copy this Python script already. This is basically what we copy from the room, and all we have to do is basically run it. So python 3 byte array.py, update your exploit.py script and set the payload variable to the string of the bad char script generated. So this is what we have to copy. Again, it starts from /x01 to /xff. So we replace the result of the thing we generated from the Python script and basically replace this with the payload and save it. Restart RDP Immunity Debugger again. So we restart that again and run it, and we save the exploit.py and basically run the exploit.py again, and we see some of the change here. So make note of the address to which ESP register point and use it in the following Mona command. So I'm just gonna copy this now. So the ESP is 0194F830. So we basically copy and paste the Mona command on the bottom part of Immunity Debugger and type out the address. So 0194F830. Press enter, and it's changed the tab around. So the bad char or the bad character is basically this. It's the same thing, and that should be your second answer here, I think. Yes. So all we have to do is switch the 00 to like the X00, X07, and then skip the 08 and type the X2E and then XA0. So we basically skip the 2F and 08. So that should be your second answer for the second task. The pop-up window should appear labeled Mona memory comparison result. If not, the window should use the window menu to switch to it. The window show the result comparison indicate any character that are different in memories to what they are in the generated binary byte array.bin file. Not all of these are bad chars. Some bad char cause the next bytes to corrupt as well, or even affects the rest of the string. The first bad char in the list should be null byte, so this one 00. Since we already removed it from the file, make note of any other. So 08 2F A1, that's we want to get rid of. Make note of any other. Generate a new byte array in Mona. Specify those new bad char along with, and this is why I get confused. So I read a couple of things and then I come back, I I lost where I'm at. So I think it's basically here. Generate a new byte array in Mona. Specify these new bad child along with x00. Then update the payload variable to your exploit.py script and remove the new bad child as well. So all we have to do here is go back to the Mona byte array and copy and paste this. So the way we want to write this is basically, let me copy it to a notepad. So this is what we want to write, and noted that, you know, we skip 08 and 2F and then A1. So we basically write 00, 07, 2E, A0 and add the X and backward slash. This is the byte array we want to type. So copy and paste that and generate it like this. So paste that to the bottom part of Immunity Debugger, and we look at the text again and see what changed. This should be the old one. I think you have to press the new. So this is what we want to copy. Actually, I'm copying the whole thing, but this is a bit confusing. So we basically generate a new byte array.text with this command down here, Mona with this command basically, and configure it to the right byte array, the bad char, the bad character. Basically created a new byte array.text. I basically copy this whole thing to my notepad, and now we got the result. Basically copy this part here, this whole part here, and paste it on the Python script. Okay, just gonna get rid of this whole thing. And to get that to run properly, I think we have to use parentheses on both sides of the payload like this. So scroll that back down. So we have to repeat the bad chart comparison until the result status return unmodified. So we save that and restart the to get this back to a normal terminal looking kind of setup. We have to press the logo, minimize or maximize, and then replay the Immunity Debugger. Again, it's so confusing, I know, but try to make sure that you follow the step of the room. I think that's helped. And if you have a notepad like I do, write it down on the note and break down step by step with bullet point, and basically going back to it once you to make sure that you're on the right place. Otherwise it can be very confusing. So have this running again with our modify byte array payload. We're gonna save the Python script, basically run the Python script again, and it seems like it's running. And basically we're going back and look at the comparisons. So we're gonna copy this line of Mona compare tag F, C Mona, oscp bit array bin tag A, and then we look at the address of the ESP. For some reason it doesn't copy and paste my thing. So this time the ESP is 018 DFA30. Press enter. All right, so it seems like the first one is unmodified, so that's a good thing. So basically whatever the next line is unmodified. So we want to see this. So when it say unmodified, this basically clean, and we could use this and basically modify it in a way to inject our malicious command. All right, now finding the jump point with the oscp.exe. Oh, let me look at the result of this first, the comparison. The new byte array.text, it should be different in here, but not really. It's not actually. We on the right track. So we remove all the bad character. Now we're gonna look at the jump point. So with the oscp.exe either running or in a crash state, run the following Mona command to make sure to update the -cpb with all the bad child you identify, including the x00. So use this line, copy it onto the command section on the bottom part of Immunity Debugger. And if you remember earlier, the bad character is basically this 00, X07, X2E, and then XAO. It's really small, but it's basically this line again. Copy and paste this input here, not this whole line, but like the input with this new command. We look at the jump point of this bad character and close that with the quotation mark, and we're gonna find the jump point here. See, this command will find a jump ESP or equivalent instruction address that don't contain any bad character specified. The result should display in log data window. So we want to look at the log data window, and that is what we want to see here. Use the window menu, choose the address, and update your exploit.py script that the return variable to the address written backward, since the system is a little endian. For example, if the address is 01x01 x02 x03 x04, it's basically doing reverse x04 x2. So it's basically doing this but in reverse. So I think it's FA110562 if I'm not mistaken. Let me consult that with Hailstorm right up, because again, I'm no professional and it's been a frustrating kind of room to figure out. Oh, so we are on the right track. So this is what we want to type in our exploit.py. So just gonna write it down, and AF, I'm gonna replace X after. So AF, basically the first line here is C, AF11. No, more like FA, because it's reversed, right? Or is it AF or FA? AF, okay, AF makes sense. So AF 115062. So we're gonna put a backward /x in front of each byte array like this, and we're gonna copy this and put it on our return part here, and then that should be pretty good. And then we have to generate a NSF Venom. So this is basically the proper exploit we use. So whatever we generate from the NSF Venom, we put it onto the payload. So I'm gonna configure this to make sure the right IP is put in. So 10.13.47.211. So update the option with the bad char you identify. So this 0x here, we're just gonna copy this and do that. This is the bad char. Tag B is the bad char we want to configure. So this is the correct way to configure your NSF Venom syntax. So tag P per payload, share was TCP, L host is equal to whatever your Kali host is, or whatever your attack box host is, IP, and then L port is your port that you're listening to. It usually is doing 4444, all four. Exit function threat, and then tag B for bad char. We identify the bad char to x00, x07, x2e, and then xa0, and the file output, or the file, is basically a C script, basically the file. As you can see here, I'm on another new tab. That's why this is useful. Basically press copy and paste the correct Metasploit command and copy this payload, paste it onto our payload Python script where the payload part is. Make sure you have parentheses on both sides of the payload. Save it and return address, basically whatever this is, and type in backward. And the offset is 1978. Padding, we basically copy this padding. So since the encoder is likely used to generate the payload, you will need some space for the memory for the payload to unpack itself. You can do this by setting the padding variable to a string of 16 or more, no operation, x90, so no op. And padding is basically this, no op times 16 or whatever you feel like putting in. So replace that with the padding part here. I'm just gonna keep it at 16, see if it works. If it doesn't work, we're gonna restart again and run the Python script again. So save that. So this is what it should look like, the proper exploit.py script. So the offset is 1978, we found from the first step. The return address is basically what we type backward on this jump point. And the padding, no op, and then time, whatever you feel like using, could be time 24. Is basically give it a little bit of room to unpack the payload. And the payload is basically whatever we generate from the NSF Venom. So this line here, payload size. I know this can be a something we want to look into more exploit like construction. Basically, I know this is more complicated, but it's not in scope of this room yet. So, and I don't know much about this anyways, because I'm actually learning like we all do. So this should be the right way we generate the payload here. Make sure I also want to add an hour to this. Oh, I still have an hour and 7 minutes, so I couldn't add an hour yet. So all right, let's see if we get the reverse shell. So save this Python script. We also gonna open another, no, actually gonna open a vertical tab here. Reason why I like to do this is just to see if it get the correct netcat. And okay, so oh no, we don't have to copy the IP. So this is basically what we do for the remote code execution. NC LVLP all four, so 4444. We get that to listen, and we launch the oscp binary out of the debugger. So we're not using the debugger this time. We want to run it like a regular binary. So where is desktop? I am on desktop. So go to vulnerable app, oscp, launch that. So it should run like a normal change the size of this. So it should run like a normal binary. So it's open up the command prompt and it's listening right now. So if I do it correctly, I configure the Python script correctly. Once I run the Python script, the exploit.py, it should give us the remote code execution, and it doesn't receive a wait, oh, we have to close this. That's why. So I know why it's not it's not running, because we're still running this on the Immunity Debugger. So we have to press X, close this down first, and launch the oscp.exe again. Okay. That was okay. So it should be listening right now. Client connection. So it listening to port 337. And if I run this, and we get the connection. Okay. So this is the first task. So the next task from here on out, from task 3 to task 10. 11, we basically do the same thing over and over again, and get it to run over and over again, basically. So who am I? I think we should be system 32 or something like that. Oh, just admin. And you know, by then you get the remote code execution. We could escalate privilege. I think we already admin. So if I do who am I /priv, oh, we have most of the privilege anyway. So we basically pretty high up in terms of privilege without getting NT authority. So that's fine. All right, that's not the scope of the room here. We basically want to configure the oscp.exe. So I'm just gonna keep this recording, but I'm basically not gonna do voiceover after this, or narrating after this. I'm basically running all the tasks. Make sure I want to complete the task, and without any narration. So I'm gonna speed the video up. If I find something trippy and I need to configure, I'm basically cut myself back and have the voice narration again. Okay, so basically should be figured out on my own from now. So let's see. And we get it. Oh man. Okay, I guess I'm finished. I'm done. I am finished. 8 full hour of sitting plus another 2 hour on the second day. All right, I'm just gonna show you my note. This is my third take on just showing the note. But anyways, so this is all my note. I want to screenshot pretty much everything in the video. Not in the video, but during the work. So everything is screenshot. I copy pretty much every exploit.py that correctly run on each overflow. So like each prefix, and yeah, there it is. If I forget the remote code execution, I want to make sure I screenshot that too. And it's a lot. It took me a total for this room to complete. It took me 12 hour in total, 8 hour in one sitting and another 2 hour today. So complete the last 2 overflow. But yeah, I mean, there's gonna be a lot of work for me to edit this. Hopefully I could do it, finish the editing by Friday and upload it. Otherwise, that is it for this video, to be honest. A long room, kind of frustrating to do initially, but it kind of rewarding too when you'll finish and get the remote code execution. But yeah, that is it. Follow the step. If you still struggling, just follow the step, retake the step. Make sure you copy all the description and put it in a bullet point like I did, and it's basically help a lot once you've done that. And rinse and repeat, you know, trial and error. I believe you could do it if you get this far. If I could do it, I'm pretty sure you could do it too. So like none of these actually in a was in a bullet point if you go back to the room. So it's pretty confusing when you're reading it, right? But when you break it down to a bullet point, it helps a lot. And yeah, that is it for this video though. Hope you have a wonderful day. Take care.